Hey everyone, and welcome. Today we're diving into a fascinating clinical detective story. It all starts with a single, pretty confusing lab report for Haemophilus influenza, one that at first glance seems to completely break the rules. Okay, so here's our case file, an antibiotic susceptibility report. And the whole mystery is right here. You see, ampicillin is listed as I for intermediate, but then cefuroxime, which is a stronger second-generation cephalosporin, is listed as R for resistant. That's our first big clue that something really unusual is going on. And that really is the central question, isn't it? I mean, you'd normally expect a second-gen antibiotic like cefuroxime to be way more effective than ampicillin. So why is it failing? This little contradiction? Well, that's our most important clue. To solve this mystery, we have to look a lot deeper than just the report itself. The answer isn't just in how the bacteria is behaving, that's its phenotype, but it's actually hidden in its genetic code, its genotype. This iceberg is really the perfect way to think about it. The lab result we can see, the phenotype, that's just the tip. In our case, it's called a BLNA phenotype, which stands for Beta-lactamase negative, ampicillin intermediate. But the real story, that huge, massive base hidden under the water, that's the genotype. And that hidden genotype, it has a name, qBLNAR. It stands for genetically beta-lactamase negative ampicillin resistant. And this is absolutely the key point here. The resistance isn't coming from some enzyme that chews up the antibiotic. Nope. It's coming from a mutation right in the bacteria's own DNA. So here's the molecular culprit right here. This qBLNR genotype comes from mutations in a gene called the FTSI gene. Now, this gene codes for the antibiotic's main target, a little something called penicillin-binding protein 3, or PBP3. When the gene mutates, it changes the shape of PBP3, making it way harder for antibiotics to grab on. It's kind of like the lock has been changed and our key just doesn't fit anymore. Okay, so now we know we're hunting for a genetic mutation. This lets our investigation get a whole lot more specific. But it turns out not all FTSI mutations are created equal. We can actually classify them into three main groups, our usual suspects, if you will. Right, so these mutations fall into three groups. You can think of them as our suspects, and each one has a different level of resistance. We've got group 1 with just mild resistance, group 2, also known as low BLNAR, and then group 3, or high BLNAR, which, as the name suggests, causes the strongest resistance. Our job now is to figure out which one of these groups is behind our tricky lab report. And this table? This is basically our suspect lineup. It shows us the typical resistance patterns for each mutation group against some key antibiotics. We've got ampicillin, our second-gen cefuroxime, and a third-gen cephalosporin, ceftriaxone. Let's use this to check the evidence from our case file. Okay, time to put on our detective hats. It's time for the process of elimination. We're going to take our evidence, that original lab report, and see which of these suspects it rules out. First up, let's look at group 1. Its key feature is that the bacteria is usually susceptible to cefuroxime. But what does our report show? It's resistant. Well, that's a direct contradiction, so we can confidently rule out group 1. One down. Now for our toughest suspect, group 3, the high BLNR. Its signature move is having resistance that often extends even to third-generation cephalosporins like ceftriaxone. But what does our report say? Ceftriaxone is susceptible. Bam, another mismatch. So we can eliminate group 3 from our investigation too. So we have eliminated 2 of our 3 suspects. Through some careful deduction, we've cornered our culprit. It is time to officially close this case and figure out the right course of action. And that leaves just one suspect standing, group 2, or low BLNR. And you know what? It's a perfect match. Group 2's profile is that low-level ampicillin resistance, confirmed cefuroxime resistance, and susceptibility to third-gen cephalosporins. This fits our report to a T. Let's just quickly recap the logic. That ampicillin I pointed us toward group 2. The cefuroxime R ruled out group 1, and the ceftriaxone S ruled out group 3. The logic is just undeniable. We are dealing with a Gram-BLNAR strain that has a group 2 PBP3 mutation. Case closed. So why does all this matter? Why go through the detective work? Because it directly tells us what to do for the patient. Our investigation confirms that second-generation cephalosporins like cefuroxime are just not going to work. But the report's susceptibility to third-generation drugs like ceftriaxone and ceftazidime is reliable. Those are our go-to treatments.
And that really brings us to the final big takeaway, the clinical pearl, if you will. The next time you see that ARMI CXMR pattern, ampicillin intermediate, cefuroxime resistant, you'll know exactly what you're looking at. It's the signature of a group 2 BLNAR strain. And you can confidently trust your third-generation cephalosporins to get the job done. Thanks for cracking the case with me today.